Okay, it's time to take the transit to the beach, and let's see what kind of observations we make. Basically, we're going to be looking for curvature. If you want to get right to the point, go to 4 minutes and 35 seconds. Let's take a look at this preliminary observation, almost 6 miles. I'm using a 25 power scope and having almost 5'2" off the ground. So here's a guy standing here about a few hundred yards away, and this corner right here is about almost 6 miles away. Let's take a look. Here we are at Vanderbilt Beach, and I'm on the edge of the beach looking between these two buildings at some new construction in here. Okay, so let's see how far that point is. That point is Doctor's Pass. So let's cruise up this way. This is a Clam Pass. All right, here's Doctor's Pass. 5.6 miles away. And here's the corner of the building, and here's the, I think, tree that we're looking at right here. So 5.6 miles away. So let's start out roughly where I think 5 feet is. Person to the right getting hit in the chin is a lot farther away. Now let's follow the shoreline using the instrument. And basically you can see how it runs pretty flat with the shore. So right here is 5.5 miles away. There's that little tree. I'm going to try to readjust it here a little bit. What I think is about 5 feet or so. Then we take off to the left. Look, it just follows the shoreline right down. Nails the guy in the back, nails the guy in the chin. That's about 5 feet. Now this is just preliminary. At this far point, there should be 20-some feet of curvature. And when you're looking through it, it's pretty easy to see that there's not. Okay, let me show you another quick observation. Okay, here's a nice clear day, and the machine back there is like 3.25 miles away. And I put it on the guy's head back there. And then, look at this guy. This guy's head lines up. The guy in the red shirt, right in the head, boom. This guy in the head. So you can see, like, it's a quick observation. Everybody's head lines up. As long as they're standing on the water's edge, the same as the tripod. Now remember, we're just taking a look around right now. Okay, now we're going to get a little more accurate using a 2x3 red marker and actual distances. So here we set our transit up at Wiggins Pass Beach Access right here. Now we put our first flag about right here, right there, 1.1 mile. And then our next flag, we put it almost to Clam Pass, 3.4 miles away. We set the transit up at 60 inches off the water's edge, and then we set our flags up at 60 inches off the water's edge. Let's take a look. My wife is holding this marker. Red flag right there. Yep, red flag right there. My friend Mike is holding the other marker.
Yeah, on the money.
Yep.
Yeah, 60, I got it. It looks pretty close, right?
Yeah.
I can't zoom in because
I know.
with the video.
Yeah.
Right, so I'll call it there.
That's it.
So my friend Anthony helped me set things up, and I forgot to interview him for the video, so I had him send me a voice clip.
The mission was simple. Meet the bear down at the beach. Set up a line of sight somewhere between 6 to 8 miles long and see if we could see the curve. Looking through there, I didn't see it.
I think he was pretty impressed, like when you swing it over and boom, it lines right up. The experiment came out great, but I want to try it again from the other direction where the sun is facing the other way. So let me show you that one, and this one we're going to really document it. Okay, so we mounted the first flag at Wiggins Pass Beach Access, and notice how we put the flag right where the water ends. This way we put the flag in the same spot in all the places, and the tripod. Okay, here's our flag, and then there's the condo that's right next to the Wiggins Pass Beach Access. We set the second marker a little bit past the last tall condominium. So we got our tripod set up on the water's edge, and this time we're right next to the woods. There is no buildings. The fire target is all the way to the left of the photo. There's no way you can see it with your naked eye. From the tripod, our first marker is 0.8 miles away. And you can see here, it's a little bit past that last tall building. We set the transit at 60 inches, and we set our markers at 60 inches. And from the transit, we're 3.1 miles away from a little bit past the Wiggins Pass beach access. And here's the observation. Of course, the wind spun the first marker around, so it's not red. We lined up the corner, and it lines right up. I don't know about you, but 2 observations in a row, the marker lines right up. I find that fascinating. The ultimate goal is to line up the flags in a row, which I try to do, but you can see they look like they're off a mile because it's magnified. So when I'm moving left, it looks like I'm moving far. But look, it's only a few degrees off here. So I mean, there's not much. It just looks like it's way to the left. Okay, so let's do the math here. The top one is a flat earth model, and you just line up the flags and you're done. Makes a ton of sense, especially after the observations too. The round earth model, here's the math of a globe that we supposedly live on, and this is the math calculations that they give us. So, okay, so at 0.8 miles, it should be 5.1 inches of drop. And over here at 3.1 miles, it should be 76.9 inches of drop. Okay, so now if we take the scope and line it up on the first flag, that means down here, we should have, you take the 5.1, you times it by 3.1, and you get 16 inches of drop. So if you take 16 off of 76.9, there should be 61 inches of air above this marker. But we don't see that. So it doesn't match the globe. On the first observation we made, you fill in all the numbers. We're at 1 mile and then 3.4 miles. There's supposed to be 70 inches in here. So the math doesn't work. Even if I was to try to fake it, what would I do? Walk around with a 10-foot flag? Or imagine like, hey, you go down there, I'm going to make this one 5 feet taller and it's going to line up. When we did the observation, the water temperature was 65 degrees. Air temperature is 75 degrees, not too far off. Okay, the reason why I brought up the temperatures is because when you have a belief system, like a religion, you got to have a way out. So here's your way out. When I line up the markers, they're not really lined up because I didn't figure in refraction. So here's your little formula right here. You got to plug that in, and then it looks flat in line, but really it's not in line. Okay, so you plug in this number and it makes it curved again. So even though I go to the beach day after day after day, line things up, everything looks completely flat, straight. It's my imagination. Okay, here's some high humidity. It's really foggy out. Yeah, obviously I'm not going to be taking a measurement today, even though I could see a guy's head like 2 to 4 miles out, and then I actually lined it up with this guy's head to the left. But even though I did that anyways, it's foggy. But yeah, I'm not going to take a measurement today. This is Bonita Beach, 4.5 miles away. It's a lousy day. It's cold, and everything lines up. There's some heads right there. They all line up. There's more heads. There's more heads line up. This guy's head lines up. He's wearing a coat. Lousy day. Things are still lining up. Okay, I'm in the same place, Wiggins Pass beach access, and today's it's miraged out day. It's almost 90 degrees. The water's 65 degrees. I line it up on that guy's head. Then I hit another person right there. Hit another person right there. We're going to cruise out to 4.5 miles, Doc's Beach House. Keep cruising level with the beach. Okay. Now we get to Doc's Beach House, and there's a person standing there. There's supposed to be almost 14 feet of curvature there. I don't see it. And today's a totally miraged out day. Now, I wouldn't even take a measurement on a day like today. You can see all the miraging in the air. I challenge anybody to bring a Transit to the beach. Buy a used one on eBay. Take a look around. I guarantee you'll be amazed.